Hello students, today we will understand about electrolyte and this class is important for 5th semester diploma students. Now, to start with this chapter, let us know about what are electrolyte and its definition. Electrolytes are the chemical compound whose atoms are closely bounded but when dissolved in water solvents like water ionizes and splits into two ions, that is anion and cation. For example, NaCl. And what is cation and what is anion? Let us understand. A cation is an ion or charged atom or particle which have fewer electrons than protons or is positively charged and thus attracted to the negative terminal of cathode. So it is attracted by the negative terminal. This is important. So it is attracted by the negative terminal or cathode during electrolysis. Now, what are anions now? A cation is an ion or charged atom or particle which have fewer protons than electrons and is negatively charged, thus attracted to the positive terminal of anode during electrolysis. Here it has been misprinted, it will be not cation, it is anion. It is my mistake, so we will just clarify this is anion. Now, what is electrode now? An electrode are the conductors of electricity which are used to make contact with the circuit with the electrolytic solution. Now, anode. Anode is the positive or positively charged electrode. Cathode. Cathode is a negatively charged electrode. Now, what is the working principle of electrolysis? Let us now understand with the help of a diagram. When an electrolyte is dissolved into a solution, forming an electrolytic solution, and the electrodes form an external energy or current source are immersed into the electrolytic solution, then the cations of the electrolyte gets attracted to the cathode and anions to the anode. You can see just in this diagram. We have a solution that is copper sulfate solution. We have given DC supplied to it. So these are now dissociated into SO4 minus and CO4 plus. So here we were there. Then the anions lose their electrons to the anode and cations get the deficient electron from the cathode, and thus creating a flow of electrons through the external energy source, thus exchanging the atoms and charges by utilizing the energy from the external energy sources. This process is called electrolysis. Now we will get the example which just I have shown to you. When electrolytic of copper sulfate CuSO4 is dissolved into water, it gives Cu++ and anion SO4 minus, which moves freely in the solution. As you can see, this is the solution. So here what the solution was? It was copper sulfate CuSO4. Now after it gets dissociated, it forms Cu++ and SO4 minus. Now if we immerse the positively and the negative terminals of the battery into the solution, then the cation copper++ gets attracted to the anode, exchanging the electrons from the cathode, and the anions SO4 gets attracted to the anode, exchanging the electrons to the anode. This process causes the deposition of copper at cathode, and the energy for the whole process is supplied by the battery through which the current flows. Now we will discuss Faraday's laws of electrolysis. Faraday law of electrolysis states that it is the first law. He states that the mass of ion or substance liberated at an electrode during electrolysis is directly proportional to the quantity of electricity transferred to the electrode. Now, mass M is equal to mass of the ions liberated. Quantity of electricity is equal to the total charge used for the electrolysis, and it is denoted by the letter Q, is equal to I into T, that is current into time, where I is equal to the current through the electrodes and T is the time for which the process of electrolysis has been run, and it is in seconds. According to Faraday's first law, M is directly proportional to Q, and M is equal to, if we remove the proportionality constant, what will be M? M is equal to Z into Q, where Z is the constant, or M is equal to Z into I into T. Now, when I is equal to 1, T is equal to 1, M will be equal to 1. And at this condition only, Z is a constant and it is known as electrochemical equivalent, or ECE, of the substance. Now, how it will be, how it will be abbreviated? This EC is the electrochemical equivalent of a substance, is the mass of the ions liberated by the passage of 1 ampere of current through electrodes for 1 second. Now, ECE of a substance is a composite function of the valency and atomic weight of the substance, and its value is given by EC is equal to 1 by F into A by B. Now, let us discuss about Faraday's second law of electrolysis. It states that if same amount of electricity is passed through different electrolytes, then the mass of substance deposited in the electrodes are proportional to their respective equivalent weight or chemical equivalent. For example, if same amount of electricity is passed through 2 electrodes, and in one electrolysis nickel is deposited in electrode and in other silver is deposited, then the mass of the respective metal deposited is proportional to their ECE, or ECE of nickel oblique ECE of argon of Ag, that is your silver, is equal to mass of nickel deposited divided by mass of silver deposited. Now let us discuss about the application of this electrolysis. Electrolysis is being one of the most important process in electrochemistry and has a lot of applications, some of which are listed. In electrometallurgy, electrometallurgy is the field which is related to the process of metal with the help of electrolysis. These types of electrometallurgy are electrowinning. Electrowinning, what is electrowinning now? Electrowinning is a process of extraction of metals from their ores. Example, aluminum can be extracted from bauxite by using electrolysis. So this was all about electrolysis. Hope you understood the electrolytic process, and we have also shown you some visuals so that it will be easy how this this solution is dissociated. So you go through this chapter. Thank you for watching.